So today's lesson will be on reactions, mostly chemical reactions, and we will also learn about different types of science instruments. So we'll learn about what types of materials are used in science and how certain reactions can happen. So this will be a fun lesson. I hope you guys enjoy. So. Let's get started. Chemical reaction, science instruments, and filtration. But first, I think it's good to review what we done last time first before we get into today's topic. Last time we learned about atoms, ions, and electron shells. So what are they again? So atom, remember, is the basic building block of matter that cannot be divided into smaller parts. They are the smallest part of a matter, and they are composed of protons, neutrons, and electrons. Like many of you guys already know, protons and neutrons are in the nucleus in the center, and electrons orbit outside. So if we look at this here, these are different types of atoms connected. So there can be same atoms forming a molecule. So nitrogen gas. It consists of two nitrogen atoms. And water, it has different atoms in the molecule, and it consists of one oxygen atom and two hydrogen atoms. You can see two hydrogen and one oxygen forms water, H2O. But here is the structure of an atom. So proton and neutron. Proton is the blue ball, neutron is the red ball, and they are all in the center. Right? The center is called the nucleus, and electrons orbit around. And remember that the number of protons should equal the number of electrons, because protons have a positive charge and electrons have a negative charge. So the atom is neutral in charge because proton number equals electron number. So this was the structure of an atom. Now let's have an example with a carbon atom. So this is one slot of a periodic table, and you can see on the top, 6 tells us the number of protons and the number of electrons. So carbon has 6 protons and 6 electrons. And in the middle, it says C. That's the chemical symbol. C stands for carbon. And below, you can see this number, 12.01. That is the atomic mass. So below is the atomic mass. And atomic mass is almost equal to the mass of nucleons. Nucleons are protons and neutrons. But because electrons are small, their mass can be neglected. Their mass doesn't need to be counted. So the atomic mass is the mass of protons and neutrons. So I hope everything is clear for everyone. And if you have a question, always feel free to ask. And now let's look at metals, nonmetals, and semi-metals, or metalloids. So this can be represented in the periodic table. So this is the periodic table, and you can see different colors, and they mean different properties. So within the periodic table, scientists have confirmed different categories of atoms. And these are the three different types: metal, non-metal, and metalloid or semi-metal. Okay. So, but to know the importance, to know why certain atoms hold their metallic properties, we need to know what ions are, because ions play a huge part in metals, nonmetals, and metalloids. So, what are ions? Well, ions can be a cation and an anion. So ion is whenever there's a change in electron numbers. And here, a neutral normal atom can be turned into a cation by losing an electron. A normal atom can be turned into an anion by gaining electron. Cation has a positive charge because it just lost an electron. Because electrons have negative charges, right? So if you lose a negative charge, the atom becomes more positive. And when an atom gains an electron, because electrons are negative, right? So when it gains an electron, the atom becomes more negative. So both of these are examples of ions. They have change in charges. Let's see how both of these work. So we have a sodium atom. So where is sodium on the periodic table? Can anyone see where sodium is? Na? It's on the left side. It's over here, right? Here's sodium on 11. So you can see sodium is metal. Let's see what it does when it forms an ion. So sodium loses one electron. So this one is gone. Now it becomes a sodium ion, and this is a cation because remember, it loses one electron. It becomes a cation. So this becomes a sodium cation. Now let's look at another example. Let's look at chlorine. So can anyone spot chlorine on the periodic table? It's called Cl. The atomic number is 17. So in the periodic table, remember, it's ordered by increasing atomic number. So hydrogen 1 to left to right, helium 2, and then now over here, lithium 3, beryllium 4, boron 5, carbon 6, and so on. If we look at all the way to 17, here's chlorine over here, right? And 17 equals the proton number and an electron number. So you can actually tell from here that it's the chlorine as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There are 17 electrons and protons. That's a chlorine atom. But now, what happens to chlorine when it forms an ion? Well, chlorine wants to gain an electron. So it wants to gain an electron, and it becomes chlorine anion. Remember, when it gains an electron, it becomes an anion and it has a negative charge. So this is chlorine anion. But you might be wondering, why does this happen? And what determines what atom will gain an electron and what atom will lose an electron? All of that, like we studied last week, has to do with electron shells. So there is a stable state for every atom, and that is when there are two electrons in the first shell, eight electrons in the second shell, and eight electrons in the third shell. And it can go on and on. It can be eight electrons in the fourth shell and the fifth shell. And the shell, I mean by this over here, one shell. This is one shell. And this is the second shell. This is where you can see in the diagram where electron seems to be orbiting. So that those are the shells, and atoms tend to have 288 electrons on them. And they form what's called the noble gas, which is stable. So let's look at an example. Okay, once you see an example, it'll be much clearer. So sodium over here has 11 as atomic number. That means it has 11 electrons, right? It wants to achieve 2. Okay, it has 2. That's nice. Main goal is 288 or 28. Let's look at this. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it has 2, 8. But what is this extra one? What is this? There's an extra electron on a sodium atom. So sodium wants to lose this electron. It wants to get rid of it because then it'll have a 2-8 structure. It'll become stable. Same with calcium. Calcium has 20 electrons. You can see 1, 2, and then all of these are 8, so it's filled. And even this is 8. So it has 2, 8, 8, and then it has extra 2, right? What are these extra 2? These needs to be expelled out. Calcium doesn't want these 2 electrons hanging around on the outside. So calcium, as a result, tends to lose electrons. And the same principle applies to the other side, to the right side. Chlorine tends to gain 1 electron. Let's see why. Chlorine has 2, 1, 2, 3, 4, 5, 6, 7, 8. So 2, 8, and 1, 2, 3, 4, 5, 6, 7. So do you notice something wrong? There is 7 on the outside. There should be 8, right? There should be 8 on the outside. And this outside shell is called the valence shell. That's the definition. And that's why chloride atom tends to gain 1 electron. It wants additional electron because that will form a 288 stable atom. Finally, let's look at sulfur. Sulfur let's see, has 16 as the atomic number. So it has 16 electrons. Let's see. 1, 2. This is good. And 1, 2, 3, 4, 5, 6, 7, 8. So that is good. Let's count the valence shell though. 1, 2, 3, 4, 5, 6. So this only has 6 electrons on the outermost shell, in the valence shell. It wants to have 8 electrons. So what do we need to do? We need to add 2 electrons. It wants 2 additional electrons. Then it will become 8. So 6 plus what equals 8? And that is 2. That is 2. And I want all of you to notice this common properties in the periodic table. So this, what I've circled here just now, this part. Do you guys see the rightmost part, the column? That is the noble gas. So this is the most stable group of atoms. And every atom wants to become a noble gas. So they need to lose or gain electrons to become these. And you can see patterns. Let's look at chlorine over here. Chlorine's over here. It's only one away from argon becoming an argon, which is a noble gas. Chlorine wants to be a noble gas. So you can see it's only one step away, so it needs one additional electron, from 17 to 18. But let's look at sodium over here. Sodium is over here, but sodium wants to go over here. It wants to go over here. How does it do that? Well, when sodium loses one electron, when it loses one electron, it becomes a neon. It becomes a neon. Because it has 11 electrons first, but when it loses one electron, it becomes 10, which is a neon. So you can notice these types of patterns, and you can guess what happens to the atom based on the periodic table. So what about fluorine? How do you guys think? Fluorine is over here, F. It's only one away, so it'll gain one electron, right? We talked about sulfur over here to 16. It gains 2 electrons to become an argon. And finally, we looked at calcium. Calcium is over here on the periodic table, 20. And it can become a noble gas over here by losing 2, minus 2 electrons. That's how every atom can be stable, by trying to reach the noble gas. That is a very graphical and great way to look at the periodic table. What you can see is that certain atoms lose electrons on the left side, right? On the left side, it loses electrons. On the right side, it generally gains an electron. And this corresponds to metals and nonmetals. Metals on the left side loses electrons. Nonmetals, which are on the right side, gains electrons. So everything makes perfect sense now in terms of periodic table. But does anyone have questions before moving on to today's topic. And if you have a question, always ask. Feel free to ask. But any questions so far? If there are none, I think I can move on to today's lesson. Okay. I'm going to stop talking now, and you guys can watch this video. It's about a chemical reaction. So I hope you guys like it. Here it is. So yeah, I hope you guys liked the video. So that was about chemical reactions, and we saw different types of reactions happen in the video. So a chemical reaction is a process in which one or more substances called reactants are transformed into one or more different substances. So this is the key distinction. They're different substances known as products. And this occurs when chemical bonds are broken and new ones are formed. And it causes the atoms to rearrange into new molecules. So I'll give you guys a little bit of time to write it down if you want. But in a chemical reaction, the total mass of the reactants is equal to the total mass of the products. This means that atoms are not created or destroyed in any sort of reaction. They're simply just rearranged. There can be excess number of energy released, or there can be energy gained in a reaction, but no atoms are created or destroyed out of thin air. Yeah, I will give you some time to write it down if you want to, but the important part is that chemical reactions transform reactants into different products by rearranging. So I will wait 30 more seconds for everyone to finish. And you don't need to write everything down, just have to know what it is. Okay, yeah, I'll be moving on now if everyone is finished. But you don't need to write again everything down. I will come back to this and I'll post the slides later too. You guys can watch the video too. And let's look at this question. So calcium oxide and water reacts to form calcium hydroxide. And the formula for the product is, so calcium oxide is this, CaO. Water is H2O. And what is the product? It is, yes, that is right. It's B. See here, CaOH2. And that is called calcium hydroxide. CaOH2, calcium hydroxide, because this is calcium and OH is hydroxide. So the answer is B, CaOH2 calcium hydroxide. And can you guys see that atoms on the left and the right are the same? There is one calcium atom on the left, one on the right. Let's see, one, two oxygen on the left, O2 on the right, and two hydrogens on the left, and two hydrogens on the right. So atoms are preserved. You can see there are no atoms created or destroyed. Okay. And here is just the different types of reaction that can happen. It's called ionic compounds can form. So we talked about ions, right? We already talked about, cations and anions. And the important thing to note is that these ions attract each other due to opposite charges. So sodium chloride, NaCl, is formed by sodium cations and chlorine anions. And calcium oxide is formed by calcium cations, oxygen anions, and etc. Magnesium chloride, magnesium ion, and 2-chloride ion, and potassium iodide, potassium ion plus iodine ion. So these are just examples of ionic compounds. And these are, again, different type of reaction that can happen. And here we already talked about cation examples, what are on the left, basically. These are metals. So sodium ion, calcium ion, potassium ion, magnesium ion, all on the left side. They're cations, so they have positive charges. They lose electrons. On the right, there are anions, which combine with cations. Examples are chlorine ion, oxide ion, hydroxide ion, sulfate ion. All of these, well, except for hydroxide and sulfate, these two are charged atoms and they are nonmetals, has negative charges. But important thing to note is just that cations combine with anions to form a new compound. Okay, that was ionic compound. But let's look at this question. The ion that causes hardness in water this is from the BECE exam, but what is an ion that causes hardness in water? Well, this is more of a memorization. You just have to know that hardness in water is caused by calcium ions and magnesium ions. You just have to memorize. So the only answer would be B, right? Because magnesium ions cause hardness in water. So just remember these two ions that causes hardness in water. Okay? And let's look at this next question. So, which of the following chemical symbols can be used to remove permanent hardness in water? So, what can be used to remove hardness? Before it was to cause hardness. Now it's to remove hardness. What can be used? So I think, can anyone come up and read this passage over here? Can anyone maybe read this part for me? here. Okay, so this is where we were before. So again, I was just asking if anyone can read this part here. So does anyone have a volunteer to read this passage? Yeah, everyone knows how to read, so if anyone wants to, you can read this passage. Are there any volunteers? Or if not, it's okay. It's just information about the question. So, the question is asking which of the following chemical symbols can be used to remove permanent hardness in water? So, what I written here, sodium carbonate, Na2CO3, also known as washing soda, reacts with calcium ion, Ca2 plus, to form insoluble calcium carbonate. So this is the reaction. Calcium ion plus sodium carbonate goes to insoluble calcium carbonate and two sodium ions. So what is used to remove it? It is the Na2CO3. It's sodium carbonate. That's why the answer is B. I just wanted you guys to be familiar with what sodium carbonate does, and it removes permanent hardness of water. This purpose of sodium carbonate. Okay, I hope this is clear for everyone. But let's look at one more type of reaction. So while we are still on the topic of chemical reaction, let's talk about what's called a neutralization reaction. So it is a chemical reaction between an acid and a base that forms salt and water. So I will get to what acid and base is in just a little bit, but neutralization reaction forms salt and water, H2. Okay. So this BEC theory question, this was actually in last year's exam. So to prepare you for the test exam a little bit, here is a question about neutralization reaction. So, can now anyone volunteer to read this passage? Can anyone read this part? Okay, if nobody volunteers, I might have to call on someone. But if one of you is speaking, I cannot hear. But
So then who went to bed immediately after eating complaints of stomach acid. The next morning, the doctor prescribed a liver salt whose major composition is NaHCO3 as the medication. Liver salt is Yes, liver salt is fantastic in neutralize acid to ability. Using a balanced chemical equation, explain how a liver using using a balanced chemical equation, explain how the liver salt will relieve the patient from this discomfort.
yes, thank you.
In the stomach.
Yeah, I think that is all you needed to read. So, yeah, thank you for reading this passage. So, this talks about a doctor prescribing a liver salt, which uses NaHCO3, sodium bicarbonate, as a medication. So, we're explaining how this sodium bicarbonate, NaHCO3, would relieve student from stomach ache. So, because acid in the stomach, we need to know what acid in the stomach is. And it is hydrochloric acid, HCl. So there are acids in our stomach. So if we have a stomach like this, there are acid in here. If this is our stomach. And that acid is HCl. It's better. HCl in our stomach. But this sodium bicarbonate, this liver salt, is a base. Notice how it's a base here, NaHCO3, that neutralizes stomach acid. So this should come in mind. Acid and a base forms a neutralization reaction. So it's HCl plus salt base equals a salt plus water and some excess products. So this is exactly what we've been talking about. Acid plus base equals salt and water. Here it's the same. HCl is acid, NaHCO3 is base, so acid plus base equals salt. Acid plus base equals salt and water. And this is called neutralization reaction. So this is a important type of reaction. It's a type of chemical reaction that you need to be familiar. So yeah, this was one of the BECE 2024 theory question. So to just give you guys a little sense of what the exam is about, but do not be too afraid um, of these questions, um, since theory questions differ every year, and this one is a particularly difficult one because you need to know stomach acid is HCl. But yeah, that was the theory question. But now let's get into simple definitions of acids and bases. So, acid, one of the properties that it has is that it turns a blue litmus paper red. So it turns from blue to red. But base, on the other hand, turns a red litmus paper into blue. So it becomes red to blue. Okay, so what litmus paper is, it's a simple pH indicator, how much acidity it has, that changes color when dipped into different types of solution. So, in an acidic solution, it's an acid when pH is less than 7. Consequently, it turns the litmus paper red, turns it red. Blue litmus paper turns red in acids, and red litmus paper stays red in acids. Acid examples are lemon juice, vinegar, or hydrochloric acid. All of these are examples of acids. But bases, on the other hand, have pH greater than 7 and turns litmus paper blue. So when a red litmus paper is dipped, it turns into blue in bases. But if a blue litmus paper is dipped in base solution, it stays in blue. Examples are soap, baking soda, ammonia, sodium hydroxide. All of these are just examples. You don't need to memorize them. Finally, there are neutral solutions where pH is exactly 7. So both red and blue litmus paper do not change color. It stays the same color either way. Examples are pure water or salt water. The water that we usually drink has pH of close to 7. It's neutral. So those are different types of solutions based on their acidity. So I hope that made sense for everyone. Talking about acids, bases, but both of these are used to explain neutralization reactions, which are acid plus base equals water and salt. And there can be excess products like gas, but those are exceptions. Okay. Now let's move on to this next part. It's about balancing chemical equations. So, first, name two elements that combines to form ammonia gas. Ammonia gas is NH3 right here. So, what are the two elements? It's nitrogen and hydrogen. You can see here, NH. Two elements form a compound. Second question, write a balanced chemical equation for the formation of ammonia from nitrogen and hydrogen. So, is this right? So, let's say because nitrogen and hydrogen exists as a diatomic, means that it just always in nature found in H2 plus N2. So now, does this go to straight to NH3? Is this right? Well, let's figure it out. On the left side, there are two nitrogen atoms, but on the right side, it only has one. So this is not balanced. This is not balanced. Because atoms do not are not created nor destroyed, we have to keep both sides equal. How can we do that? Well, let's balance the nitrogen first. So on the right, we can add 2. So it becomes 2NH3. So nitrogen is balanced, but notice how hydrogen is 6 on the right. Hydrogen is 6 on the right, but hydrogen is 2 on the left. We can make these equal by multiplying the left hydrogen by 3. If we do that, then hydrogen on the left becomes 6. Because 3 times 2 equals 6. And on the right side, similarly, 2 times 3 equals 6. So that is how you would balance a chemical equation. And here is the final answer. N2 plus 3H2 goes to 2NH3, 2 ammonia molecules. To give you guys a better sense, let's look at more examples. So I have plenty of examples that we can do together. If this might be a little challenging, a little difficult at first, but I have a lot of examples that we can do together. So let's look at this question. The number required to make the following chemical equation balanced is. So what number would we add in order to balance this equation? So let's analyze this reaction. So first step, oxygen, O2, has 2 oxygen atoms, right, on the left side. To balance the oxygen, we need 2 H2O molecules, so we put 2 in front of H2O. Second step, 2H2O has 4 hydrogen atoms because 2 times 2 equals 4. And to balance hydrogen, we need 2 H2 molecules on the left side. So we add 2 in front of H2. Now we can see it becomes 2H2 plus O2 goes to 2H2O. Right now this is balanced, but what we can also do is we can divide both sides by 2, and we get this. H2 plus half of O2 goes to H2O. Because it's just asking for one number required to balance, the answer would be 1/2. Because if we put 1/2 in front of oxygen, this equation becomes balanced. So if we put 1/2 in front of oxygen, oxygen on the left becomes 1, and both sides are balanced. Okay. So the answer is A. So I have actually a couple more examples we can do together. So let's do this. So which of the following chemical equations is balanced? So can anyone tell me, is A balanced? Do you guys think A is a balanced equation? It's no, right? It's not. Because there are two hydrogens on the left, but only one on the right. It's not balanced. Let's look at the second one. Is B balanced? Yeah, it's also not, right? Because there are two potassium on the left, but only one on the right. It's not balanced. Let's look at three. Is C balanced? Do you think C is balanced? See how there are two oxygens on the left, but only one on the right side? So this is not balanced. This leaves us with D. We can see this is balanced because we have two sodium on the left, two sodium on the right, two calcium on the left, and two calcium on the right. Because 2 NaCl is the same actually as Na2Cl2. So D is the only balanced one. So the answer is D. Okay, so lastly, let's just look at this. So yeah, these are the ways you can balance the previous equation. So you can balance A, this A, by adding 2 in front of HCl. You can balance B by adding 2 next to K2O and 4 next to K. You can finally balance C by adding 2 to the product MgO and 2 to Mg magnesium. Okay, so this last topic for today is going to be on science instruments, which I think we will cover next week because we do not have too much time left. So I will save this for next time. So next week we will learn about um science instruments, and we will also learn about heat transfer, energy transfer, and thermal energy. So all of those will be covered next week. So are there any questions for today? Because I know um, balancing equation can be a little difficult. So feel free to ask me a question if you have. So are there questions, anyone who wants to ask? So yeah, does anyone have questions? Always feel free to ask. I don't mind answering questions. Um, but what we covered today goes just from, chemical reactions. We talked about
Yes, fine.
yes.
Fine. Fine. Fine.
Okay, yeah. You
Next
can
slide.
type me the question.
The next slide. Okay. Okay. Hello, can you hear me?
Yes. Oh, to the first slide. Okay. You mean this slide or
Hello.
oh, so do you mean this slide or is this the slide that they wanted to copy or was it this one about balancing equation or
Okay. Are you there? One. The liver salt. Liver salt. I said it's this one. This one. This one.
oh, okay. Um, can you hear me now? Is it better?
We can hear you, but I don't know whether you can also hear us.
Oh, I can also hear you. Yes.
You said liver salt question. Please, can you go to the liver salt question? The question containing liver salt.
Oh, okay. The liver salts. I will put this over here. So, yeah, this is the question.
This one. This one. Hey, don't you want to copy it? You can copy it. Okay. Hello. Okay, don't you want to copy it? You can copy it. Now we'll find it. Yeah. Parents room.
If you have a question, I can't hear you. If you're asking. Yeah, maybe can you type out your question in
Let's
chat?
element. Which ones are the metal and non-metal?
Is it a question about matter? Sorry, can you type it
Yes,
in?
she was talking about the
Yeah.
first 20 elements. Which ones are metals and which ones are non-metals?
Oh, is it about matter? Let me type. Is it about matter or maybe? Yeah, sorry, I couldn't hear you very well, so can you maybe type the question? Yeah. Oh, you want to go over first 20 elements? Oh, the metals and non-metals. Okay. Okay, yeah, I can definitely go back to that. Um, but is okay, yeah. Yeah, are you finished writing down? Then I can go back
Yes,
to
yes.
okay. I can
Wow.
go
Yeah,
back to metals, non-metals. Okay. So the difference between metals and non-metals is that metals are malleable, which means that actually, let me pull up another slide from last week. This had more details. So, so here is metal. So metals are on the left and center of the periodic table. So left and the center. Metals are shiny. They are very shiny. Metals are good conductors of heat and electricity. Metals are malleable, which means that they can be shaped into multiple different shapes, and they are ductile, which means that they can be stretched into wires. Metals are usually solid at room temperature. And finally, metals tend to lose electrons. Metals lose electrons. So examples are platinum, like copper, iron, or gold. All of these are metals. So, uh, okay, yeah. But these are some properties of metals. Again, metals are shiny, they're good conductors, malleable, ductile, solid, and they lose electrons. Let's look at nonmetals. So nonmetals do not have properties of metals. They're found on the right side on the periodic table. And nonmetals are poor conductors. They are not shiny and are brittle. And they can be solid, liquid, or gas at room temperature. And finally, they tend to gain electrons in reactions. So I hope that answered your question about metals and nonmetals.
Yes.
Okay.
Big question.
Well, there was another type of element called semi-metal, which is having properties of both metals and nonmetals. And they're semiconductors, which means that they conduct electricity better than nonmetals, but not as well as metals. So in the periodic table, these are metalloid semi-metals in green. You can see nonmetals are on the right and metals are on the left. So yeah, I hope that answered your question about metals and nonmetals. Examples of like metalloids are, silicon, boron, etc. Yeah, any other questions? Um, if there are, yeah, no questions, then yeah. Mhm.
Any other question again? Okay. So JB, no more questions.
Okay, yeah, then I will see everyone next week. And next week we will be learning about science instruments, heat energy, energy transfer, and yeah, those will be topics next week.
It's energy and energy transfer.
Okay, yeah. I will see everyone next week then. Okay, yeah. Bye everyone. Bye.